Now discuss higher order functions. Let me increase my screen size. What is higher order function? The concept is simple. Higher order function is one function which can take some other function as an input parameter, or higher order function is a function which can return another function as output. Okay. Now Scala has powerful support for higher order functions, and we'll see that Scala collections, collection means a data structure which basically is a collection of items, right? And we'll see that Scala collection supports higher order function, and that means we can use an anonymous function as an input parameter to those higher order function, and that anonymous function can be applied to each item in that collection. And one example of such higher order function is foreach method, which is applicable, or which is available in most of the Scala collections. And we'll see that that can take an anonymous function which looks like a code block, and that anonymous function can be applied to each item in that collection. Let's take an example quick for each that higher order function. So here we are creating a list that has 3 items. So list is a collection and data structure, right? And list supports this higher order function for each. So this method is available in list. And what does it do? It takes another function, which is an anonymous function as written here in blue color, as an input. So for each is a higher order function which is taking an anonymous function, this blue color stuff here, as an input. And what does this anonymous function do? Anonymous function has one parameter x, and the body of the anonymous function can be anything. Here it is printing the parameter x. So this blue color stuff is the anonymous function. Now what will be the overall impact of this code? So what for each will do with this anonymous function? For each will apply this blue color function on each item in the collection. So this blue color function will be applied to the first item, Frodo. What will be the output after that is applied? So Frodo is x, and after we apply this blue color function on the first item, Frodo will be printed out, correct? Similarly, this blue color function will be applied to the second item in the collection, and Samwise will be printed out, and similarly Pippin. So the output will be this, okay? Now see the analogy of this syntax of this anonymous function with our regular algebra function, right? So we are familiar with this fx, the typical function in algebra, where x is the input and fx is the output, right? And see the analogy with this anonymous function to that. And soon you will realize in functional programming we almost do things like what we do in math, okay? So that is there. Now let's talk about for each the same higher order function in the context of other collections like sets and maps. So here there is a set, 3 items are there, and if we apply this higher order function for each on this set, and this for each is taking this anonymous function, right, similar than like before, and then this Frodo will be printed, and then this anonymous function will be applied to the second item, Samwise will printed, and so on, correct? Now let's talk about a map, which is another type of anonymous function, right? I'm sorry, map is another collection, right? So here map has 3 key value pairs, right? and we can use this for each higher order function on this map, and that is taking this anonymous function. So this anonymous function will be applied to this first item, and remember, for a map the first item is the first key value pair, right? So this key value pair will be printed when this anonymous function is applied to the first key value pair. Then this anonymous function will be applied to this second key value pair, right? And this will be printed. And similarly, this anonymous function will be applied to the third key value pair, and this key value pair will be printed. Okay. Now, if you want to, if you don't want to print this key value pair, and you want only the first item in the key value pair, that means only Frodo, Samwise, and Pippin, then instead of printing this whole X, which is this key value pair, you can print the first item in this tuple. Remember, we learned this syntax in the context of tuple, right? The first item in the tuple. So the output of this code will be Frodo, Samwise, and Pippin being printed. Okay, more higher order functions. Words is a list which has 4 words in this example, and then we are applying a higher order function map on this word. It's almost like for each. What map does, it takes this anonymous function and applies this anonymous function to each item in the list. What is the meaning of this anonymous function? Given a word, we are going to output the size of the word, right? That is the meaning of this anonymous function. So this anonymous function will be applied to the first item. So peg is the word, and the size of peg is 3. So output from this item will be 3, correct? Then similarly, this will be applied to this second item, and AL will be the input, and the size is 2. So output from this item will be 2, correct? And similarly, this will give us 3, this will give us 1, 2, 3, 4, 5, right? So the output of this code will be a list of integers, these sizes 3, 2, 3, 5, correct? Which were the output of applying that anonymous function on each of these items separately. And those outputs will be collected together as a list, and that list will be returned as the ultimate output of this map. Remember that this is an important thing in Scala. Okay, let's take more higher order function. Count is the next one, and what does it do? It can count how many items in the collection satisfy some given constraint, like this one. So the given constraint here is an anonymous function. What is the meaning of this anonymous function? Given a word, we are going to check whether that word size is greater than 2. So remember, here the output of this anonymous function is Boolean, right? It gives either true or false. Makes sense? So what count does, it applies the given anonymous function on each item. So this will give us this Boolean 3 greater than 2 or not, and 3 is greater than 2. So this item will give us true, correct? After applying this anonymous function on this item, it will return true. This one will return false because the size is 2 here, so this logic fails there, right? So this will return false, this will return true, and this will return true. What count does, it counts from how many items we have got true result after applying the given constraint, right? So here the result is just 3. Make sense? Now we have another higher order function called filter, and what it does, it is similar to count. The difference is it collects those items in the list for which the given constraint gives us true result. So here we count was returning 3 as the output. Filter will return that subset of items in the list for which the given constraint is true. And if you remember, for Peg, Bud, and Kelly, the given constraint, the given anonymous function was true, and that will be returned as the output of filter. Okay,